This player begins at the same point in all 3 runs. With the same amount of right arrow input, a speed of 320 moves farther than 240. Then we restore 240 and prove the original pace is back. You're watching Chris Markins. In this lesson, you will change one number, judge the result in play, ask an AI agent to explain and audit that bounded change without editing anything, and finish with a clean Chapter 1 checkpoint. You remain in control of every project change. Start from the Nightbloom Chapter 1 starter used in the previous lesson. This project is locked to the standard Godot version 4.7 stable build and the compatibility renderer. Before changing anything, run the project, click inside the game, and make sure every arrow key still moves the blue player. For our comparison, place the player at the visible start marker and hold right arrow for the labeled input window. The production measurement will use the same start and duration for every value. Your home test does not need frame perfect timing. You only need a clear, repeatable difference. Stop the run when the baseline passes. In the File System panel, open Scripts and double-click CH01demoplayer.gd. Find the exported speed line. The word float means this setting may include a decimal part, which is why the value is written as 240.0. Write down that starting value before you touch it. Speed is measured here in screen pixels per second. The script combines the input direction with this speed to create velocity. Then Godot moves the player. A larger value should cover more distance in the same time, but that explanation is only a prediction until we run the game. Before the edit, say the prediction out loud. 320 should move farther than 240 during the same input window. Now select only 240.0. Type 320.0 and leave every other character on the line unchanged. Press Ctrl+S to save. The viewer makes the edit directly. The AI receives no permission to write to the project. Before you run, make a prediction. 320 is larger than 240, so the player should travel farther during the same input window. Faster is not automatically better. We are testing how the value changes the feel, not trying to maximize a number. Run the project again and click inside the game. Begin from the same marker. Then hold right arrow for the same label duration. At 320, the player should finish farther to the right than it did at 240. That observed position change is the proof. Move left and right for a few seconds as well. Decide whether the faster pace feels responsive, hurried, or simply different. Your judgment may differ from mine, and that is the point of tuning. Stop the run before editing again. If nothing looks faster, check the smallest causes first. Confirm that the open file is scripts. CH01demoplayer.gd. Press Ctrl+S. Stop the current run. Launch a fresh run. Click inside the game. And repeat the same movement. An unsaved value or an unfocused game window can make a correct edit appear to do nothing. If Godot shows a red marker or reports a parser error, stop the game and compare the whole exported speed line with the no good line on screen. Restore every character, including the decimal point, save, and run again. Do not let an AI rewrite the file to repair a one-number exercise. Now restore the known good value. Replace 320.0 with 240.0 and press Ctrl+S run from the same marker with the same input window. The player should return to the baseline distance. A successful restoration matters as much as the experiment. The game has already shown us what the value does. Now an AI can help explain and audit without taking control. If you use a local coding agent, open the starter as its project root and confirm that the file list includes project.godot, scenes, and scripts. Do not show or share any account details. Give it this boundary. Read only scripts. CH01demoplayer.gd. Do not edit, create, rename, delete, or run anything. In 3 plain sentences, explain what changing the exported speed value changes. Identify the one line that differs between 240 and 320, and name the playtest that checks the explanation. Do not propose new features. With a web chat, paste only the exported speed line before the same request. With no AI, answer from the faster and restored runs you just played. On every route, keep the observed gameplay result if an explanation disagrees with it. The AI response is commentary, not proof. Review the difference instead of trusting a summary. The before version says 240.0. The experiment says 320.0. Every other character on the line stays the same, and the current saved version is restored to 240.0. Before we create the checkpoint copy, the restored authored file receipt should show 0 changed authored files against the normalized 240 baseline. Godot may update generated cache files inside .godot. Those are not authored project changes. If an authored script, scene, or project setting changed at this stage, stop and return to the clean starter. Later, we will intentionally rename only the copied project's display name. Make one more judgment without asking the AI. Before editing, predict whether 180 should cover more or less ground than 240 during the same input window. Then replace 240.0 with 180.0 and save. Run, click inside, begin from the same marker, and repeat right arrow. At 180, the player should travel less distance in the same time. You have used one code value to test game feel instead of treating code as a spell to copy. Stop the run when the prediction is confirmed. Restore 180.0 to 240.0 and save. Run once more from the same marker. The final position should match the original pace closely enough to confirm the restoration. Stop the game and leave the full saved speed line visible. Exported speed, float, equals 240.0. Stop and close Godot. Copy the complete Nightbloom Chapter 1 starter folder, paste it beside the original, and name the copy Nightbloom Chapter 1 moved and restored. Import the copied project.godot through the Godot version 4.7 project manager. If the copy is already listed, select its card and choose Edit. Open Project Settings. Under Application, Config, set the project name to Nightbloom Chapter 1 moved and restored, then close Project Settings. Run the copy and press left arrow. The checkpoint passes when the player moves and the script still shows a speed of 240.0. If the copy fails, close Godot and mark that checkpoint with failed, do not use. Reopen the original starter and confirm it still plays at 240. Then close Godot and copy the working folder again. Never overwrite the known good starter with an uncertain checkpoint. You changed one speed value, proved the faster and slower results, used an AI only for a read, only explanation and audit, and restored the known good pace. The Chapter 1 checkpoint now preserves the tested state. Next, we will learn the 6 parts of the Godot editor by asking what each one owns. This tutorial completes Chapter 1 of Make Your First Godot Game with an AI Agent. The book gives you the exact click path, permanent code reference, recovery checkpoint, and tests behind what you just saw. The free Chapter 1 materials and the book are linked below.